Alright, in section 5.5, day 2, I'm going to look at 3 problems to help you out. First one is going to ask you to find the exact value of the cosecant of x over 2 if, and then they give you a triangle. So should be able to identify that that's a half angle formula because it's x over 2. So hopefully you can quickly identify which formulas to use. This one they're a little nice, they actually tell you to use the half angle formula. I probably would not do that on the test. You should be able to recognize it when you see the x over 2 that is the half angle formula. So find the exact value of the sine, the cosine, the tangent of x over 2 given this. Very same, I mean it's very similar information. Here they're asking me to find 1 instead of 3 trig functions, but same idea. They gave me the triangle, they gave me enough information to draw the triangle. So very similar in terms of what they're doing. And then the last one is going to be a verifying problem, which deals with one of the identities that we learned in section 5. Alright, so let's start with the first one. Find the exact value of the cosecant of x over 2 if given that triangle. Well, if I want to, I can go ahead and figure out what the hypotenuse of that triangle is, and I probably would do that right away. It's one of my Pythagorean triples if you remember it. If you don't remember it, you can obviously run through the Pythagorean theorem to find out that that's 17. I know it says cosecant. I'm going to actually find the sine of x over 2 using my identity, and then of course I'll just take the reciprocal at the end. So the sine of x over 2 is equal to plus or minus the square root of, and it's 1 minus the cosine of x over 2, and that's all inside the radical. And of course that's beneficial because the cosine of x, well, I can figure out the cosine of x by looking at that triangle. So I actually have to know what that hypotenuse is. So how do I figure out the plus or minus? Well, I don't know the specific angle in the first quadrant, but pick any angle you want in the first quadrant. If you divide it by 2, where is that angle? It's still in the first quadrant. If you took 80, divided it by 2 would give you 40. That's still in the first quadrant. If you took 30, divided by 2, that's 15. It's still in the first quadrant. That means the sign in the first quadrant is going to be positive. So it's positive, which is obviously implied. You don't need to put it there. The square root of 1 minus, now the cosine of this triangle, the cosine is 15/17. And then I divide that by 2, and again, that's all in the radical. And now I just have to simplify, and I'll have my answer. So this is going to give me square root of 17/17 minus 15/17 all over 2. Or, of course, that's going to give me the square root of 2/17 over 2. And remember how that works. If you multiply by the reciprocal, the 2 would actually be in the denominator. So this is eventually going to give me the square root of 1/17. And of course, if I take the square root of each separately and then rationalize, I am going to get 1 over the square root of 17. Rationalizing will give me the square root of 17 over 17. Excuse me. And so for that particular problem, your answer should just be square root of 17 over 17. Alright, hopefully you could figure out why I know it's positive instead of negative. It can't be both, it's one or the other. And then hopefully you're able to follow the calculations. For this particular problem, like I said, it's almost the same thing. First thing I want to do is I want to mess around with this, and I want to get my triangle drawn like I had here. And then it's just doing 3 separate problems basically. So looking at this, yeah, I know it's the cosecant. I'm going to deal with the sine because I'm more familiar with that. That's going to give me negative 3/5. And I can see here it's telling me it's in the third quadrant. So when I draw my triangle, I will make it look like it's actually in the third quadrant. Here's my angle x. The sine was negative 3, hypotenuse 5. That means I know the cosine, or the x value, I guess, on my unit circle, or this distance, is negative 4. Remember, it's negative because it's going to the left. Alright, now that I've got the triangle drawn out, now let's try to find the sine of x over 2. Well, same identity as we just got done using on this previous problem. It's plus or minus the square root of 1 minus the cosine of x over 2. So, now, how do I figure out the plus or minus? Well, we're in the third quadrant now. So pick any angle you want in the third quadrant. Anything between 180 and 270. So for example, I'm going to pick 200. Well, that's saying that this is 200 degrees. I want to know what the sine of, it's not actually 200, but we're just pretending. If it is actually 200, I want to know what the sine of 100 degrees is. Ask yourself, where is 100 degrees? It's in the second quadrant, which means the sine of it is positive. So this is going to equal positive square root of 1 minus, the cosine is going to be negative 4/5, so that's going to change this to positive 4/5 over 2. And getting a common denominator, that's 5 over 5, so this is going to be 9 over 5 over 2, or that's going to give me the square root of 3/10 eventually. Sorry, not 3, 9/10. And then I'll take the square root of both separately. That gives me 3 over the square root of 10. I knew the 3 was coming eventually. Take this, rationalize both, rationalize is what I meant to say. You should get 3 square roots of 10 over 10. And that's what the sine of x over 2 is. Now if I want to find out what the cosine of x over 2 is, basically, same idea. You just have to run through the formula again. It's plus or minus the square root of 1 plus the cosine of x over 2. Again, let's do that little pretending thing. If I'm talking about 200 degrees and I want to find the cosine of half of that, so the cosine of 100 degrees is in the second quadrant. The cosine of this is going to be negative. So it's negative square root of 1 plus a negative 4/5, because that's the cosine of this triangle, over 2. That's going to give me, if I change this to 5 over 5, it's going to give me the square root of 1/5 over 2. Which is eventually going to give me the square root of 1/10. Take the square root of both separately, I get 1 over the square root of 10, and when I rationalize I should get negative square root of 10 over 10, because remember this is a negative. And now to do the tangent, you can easily plug it through the formula, or it's the same angle, so you could do sine over cosine. That's what I would do if I was doing this problem. I'm going to show it all the way out just in case, like I said on the test, I ask you to specifically find the tangent, then there's really no reason to find the sine or cosine. So for tangent, you have two formulas. You can either use 1 minus the cosine of x over the sine of x. Whoops, I don't know why I wrote 2. So it's 1 minus the cosine of x over the sine of x. Or if you don't like that one or don't want to use that one, you can use the sine of x over 1 plus the cosine of x. Either one, it gives you the same answer regardless. So it's not going to make a difference. I'm just going to pick this one. If I plug in, negative cosine is already negative 4/5, so that's going to give me 4/5. Divided by the sine of this triangle is negative 3/5. And if I simplify, I'm going to get 9/5 divided by negative 3/5, or multiply by the reciprocal. I'm going to end up with negative 3. And you can see if you divided these two, the denominators would cancel. 3 square roots of 10 divided by negative square root of 10, you would eventually get negative 3. So if you had to find all three, find these two and then just divide to find the tangent. I just ran through that one just in case you're asked to find that. Alright, and then the last one is going to be a verifying problem. And what I want to recognize on this particular problem is that I have two cosine functions with different angles being added together or subtracted. And then in the denominator I have two sine functions with different angles being added or subtracted. That clues me in to use the sum to product formulas. So that's something that unfortunately you have to recognize. If you don't recognize that, there's not much you can do with this problem. So hopefully you can identify that. Again, if you looked at just the numerator, it's two cosine functions with two different angles being added or subtracted, and then basically same thing in the denominator. It's two sine functions with two different angles being added or subtracted. So if I look at just the numerator and I use the identity for that, I know the identity for two cotangents added together with different angles is going to be, it looks like it's 2 times the cosine of the angles added together and then divided by 2. So t plus 3t divided by 2 times the cosine of the angles subtracted and then divided by 2. And this is considered the u, the first one, and this is considered the v. So t minus 3t divided by 2. There's the numerator's identity. The denominator's identity, similar, just a little bit different. It's going to be 2 again, times, make sure you get the right one, it's the sine with them being subtracted. It's the cosine of the angles added together, so 3t plus t. This sign just tells you which identity, doesn't affect what you're doing in here. So 3t plus t divided by 2 times the sine of the angles subtracted. And again, this one's always first. So 3t minus t divided by 2. And now I just need to simplify a little bit more. Obviously I can see the 2's are going to cancel, so I can ignore that. You probably can see that this is going to give you cosine of 2t and then cosine of 2t. These eventually are going to cancel. This one is going to give you the cosine of negative t, and the denominator would give you the sine of t. And again, those canceled. So if you see they cancel up here, you can go ahead and cancel them. If you don't until you get here, that's fine. So you are left with the cosine of negative t divided by the sine of positive t. Now I see what the answer is. It's just the cotangent of t. So you might be looking at that saying, well, wait a minute, they're different angles. I can't have that. I need it to just be cosine of t. Well, when we first started doing all of this simplifying, some of the things I said you want to look for is you want to look for a trig function squared, you wanted to look for a 90 minus theta, and you actually wanted to look for a negative angle. If you go look at your identities, the cosine of t is equal to the cosine of negative t. So that's actual rules. I can change that into cosine of t divided by sine t, and now I have what I'm looking for. I have that that's equal to the cotangent of t. All right, the biggest part of this problem is recognizing the sum to product in both the numerator and the denominator. Unfortunately, if you don't recognize that, you'll get stuck. Hopefully that'll help you out for your homework in 5.5 day 2.